Look at graphing a sinusoidal function. And these are the requirements. A sinusoidal function where the equation of the axis is at 1, amplitude is 5, and the period is 6. So these are our 3 key points. We'll quickly go over them again. Equation of the axis, okay, that's a very specific part of a sinusoidal equation, okay, is one. The amplitude, another very specific part, and the period. So these are really our 3 keys, and everything else is vague, so we can kind of go where we want from that. Now, when graphing one of these, it depends. You're probably used to graphing an actual sine wave or something. A sinusoidal function is a periodic function, and a periodic function is any function that repeats. So I'm going to just put a rough sketch of a coordinate plane here, and a periodic function is just something that repeats. Okay, so this very rigid straight line one is periodic, but this would not be sinusoidal because sinusoidal has a wave-like pattern to it. Okay, so we have to make sure if we're graphing sinusoidal that we have some type of wave-like pattern. Okay, that's the first requirement of what they've given us. The second one says the equation of the axis is at the value of 1. Okay, the equation of the axis of a sinusoidal, okay, is the line that runs right through the middle of it. So you almost have to find the average of the highest and lowest peak of a sinusoidal function. So you add the two together, divide by 2, and that's where the equation of the axis would be. Now they actually told us the exact coordinate. Okay, it's at 1. So because it's a horizontal line, we're looking for a y value of 1. Okay, so and I'm going to have to build some type of scale here. Now the problem is, and depending how good we are with this, we're not really sure what scale to build. If I were to go, 1, 2, 3, is this going to be big enough for what it is? I can tell you that it's not because I know the amplitude, okay, and I don't want to talk too much. I would like to show you some visuals. But the amplitude is an extension from the equation of the axis. It's how far up and down you go from it. So if we're at 1, that means we have a high point of 6 and a low point of -4. If I go 1, 2, 3, this scale is not going to be big enough. There's nothing wrong with trying a scale and discovering that's no good. I have to redo it. Okay, but that being the case, I'm going to go up by 2. Okay, so 2, 4, 6. This will be our y value 0, -2, -4, -6. So what that means, the equation of the axis, so we go back to that yellow point, if I can make it yellow, is a horizontal line at 1, so halfway through. There's the equation of the axis. Kind of a hard color to see, but that's the middle of our function. Okay. We also know it has an amplitude, okay, of 5. So like I said, it goes up 5 units from there, so 1, 2, 3, 4, 5. So like we said, a highest point of 6. So we know that the highest value of this sinusoidal wave, I want to use a green, okay, and I want it to be pattern. The highest point is going to be there. And the lowest point, well, we take that 1 and subtract 5, will be at -4. So here's our lowest point. So the dotted lines are lines you draw, and even the equation of the axis isn't a line you normally draw, but they help us give us reference points, okay? And they've also said that and those actually deal with all of our kind of y values, amplitude, equation of the axis. That's what we need to know for y. The x values refer to the period. The period of the function is 6. Now in the question I didn't write it down, they want us to draw 2 cycles. So again, for my scale, if I went 1, 2, 4, 5, 6, I'd have to go do 12, and I don't quite make that, so that wouldn't be a very good scale. So again, I'm going to go by 2s. Okay, so we go 2, 4, 6, 8, 10, 12, 14, 16. So we're way past where we need to be. Okay, so the period occurs every 6. Okay, they didn't tell us where we start. We always go on the assumption that our y-axis here is the start. Maybe you're riding a Ferris wheel and it's time. This is where we're starting. Okay, do we start at the highest point? Do we start at the equation of the axis? Do we start at the lowest point? Not said in the question, so I can do whatever the heck I want. Probably easiest a common place to start is the lowest point, but I'll show you using the highest point where we can make it really easy for ourselves if we start there. So maybe we'll start there and we'll draw a different one after. If I start at the highest point, that means I'm going to go all the way to the bottom and then back up to the highest point. I'm going to reach that same highest point again after 6 units, 6 seconds, whatever you want to call it. Okay, so because it's a wave-like function, that means we reach the lowest point halfway between these 2 values. So halfway between 0 and 6 would be the number 3. So number 3 is where we'd reach our lowest point. So it gives us some good references in drawing the wave. Okay? And then from there, between the highest and lowest point is the middle, the equation of the axis. I would reach that halfway between those points. So we could keep using the idea of half. Okay, so remember, it took 6 seconds to get there, which means it'll only take 3 seconds to get halfway there, which means it'll only take 1.5 seconds to get to our middle here. Okay, so 1.5, oh, we say is about there. And then 1.5 from 3 is 4.5, so something like that. So our wave can take on this type of pattern. Okay, and then we can repeat that from 6. If it takes 6 seconds to repeat again, when will we be at our highest point? If we're at 6 now, when will we be at our next highest point?
The next highest will be at 12.
At 12, great. Okay. Did I do that? Did I draw this right? Yeah, I think I did. Yes, good. Where would the next lowest point be?
At 9.
At 9. Good. The value 9, I know they don't write it in. And the equation of the axis, these ones are a little harder to figure out because they're halfway between our value of 6 and 9.
7?
Yeah, it's not quite 7, it's 7.5. So it's 7.5, and then here is 10.5. Again, a little harder, and all you have to do is add 1.5 to 6, add 1.5 to 9, okay? And then we continue our pattern. I kind of missed that there. But this is our sinusoidal wave, and that continues. Again, it actually goes to 18, 15, 13.5, 16.5. We drew 3 cycles of our sinusoidal wave now. Okay, so it also asks us to draw some key points. Okay, so here's a key point. Our x values 0 and 6, right? Another key point is at 3 and -4. Another key point is at 6 and 6. Okay. Now there's 1, 2, 3. When they usually say 5 key points is they're looking for the highest point when you cross the equation of the axis and the lowest point. Okay. So the equation of the axis, that was a little tougher to calculate. If you remember, that was 1.5 and 1. Okay, so we added 1.5 to 0 because 1.5 was halfway between 0 and 3. And then we add 1.5 to 3 to find the next point, and that's actually 4.5 and 1. Again, you could have drawn out all of these coordinates here, but that's a general idea of how to graph a sinusoidal wave. A bit of mental math. We had to do a bit of mental math. It's usually for the scale of the equation, right? For the equation of the axis, the amplitude give us our y ideas for our y coordinate, and the period helps us set up our scale for the x-axis of the function. Okay?